Start this up. So let me ask you guys have any questions, any homework questions, any topic questions, anything? Mhm. We all good? Tomorrow. Yeah. 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 But I am more than halfway through it. Like and just as a general overall, just telling y'all like I'm really impressed. I'm happy, you know. Like it's definitely an improvement from last time, right? And again, if you don't do so well, it's okay. You have another test coming up, right? This was going to be even easier than the first two, you know? So it's all good. Exactly, you know? So this, oh wait, let me get where's my tool at? Here we go. All right, just bear with me 1 second. All right, before we get into today's topic, I just want to start off with a little blast from the past. Am I good? All right. How do I do this? Or you can just tell me how to do it. Like, say it again. Add what? Add five to both sides. Very good, right? Because I want to isolate the variable, solve for it. What you do to one side of the equation, I have to do to the other side of the equation. So now I have 2x is equal to 5. And what do I do after that? Exactly. Divide both sides by 2. What you do to one side, you have to do to the other. Excellent. So my final answer, x is equal to 5 over 2. Okay. Any questions on this? Anybody? We good? All right, I have another blast from the past question. So the instructions on this question tell us to simplify. I feel like expand is a better word, right? So tell me how to do this. Mhm. Okay, fair enough. But how do I square it though? So I have y minus 3 squared. How do I square that? Uh, close, right? So look, we have two ways we could do this, right? You can either FOIL it or you could use a trick, right? Remember though, FOIL works for all of them, right? FOIL is a fancy way of me saying distribute, right? So you could do y minus 3 times y minus 3, and then just first, outer, inner, last. You could do it like that, right? And then we'll come out with what? Y times y is y squared. Let me redo these real quick. So y times y squared. Then we want to do y times negative 3, negative 3y, then negative 3 times y, negative 3y. And then now, last but not least, negative 3 times negative 3, positive 9. Combine like terms, so this is what? Y squared minus 6y plus 9, right? I lied though. There's three ways we could do this. That was one way, right? Another way that we could do this, just to recap real quick. So I have y minus 3 squared, right? So you could break it apart, right? So you could have y times y minus 3. minus 3 times y minus 3, right? It's another way we could do it and then just distribute and combine like terms, right? Bam, bam. So we get what? Y squared, y times y, then y times negative 3y, then negative 3 times y, negative 3y, then negative 3 times negative 3 plus 9. Combine like terms, we have y squared minus 6y plus 9. All right. These two methods work for anything, right? So if there was a method that, say, you just wanted to remember one thing for your test and that's it, this is the one thing to remember. All right. The next method, go ahead. Yeah, so this is FOIL up here. And this is just another method of distribution. Either way works. Whichever way you like better, that's the way you should choose, right? But there's also a third method, right? So we learned a shortcut, right? You remember when we have a minus b squared? That's the same thing as a squared minus 2ab plus b squared. I don't know if we remember this, right? So for my question here, what do I have? I have y minus 3 squared. So what's that going to be? It's going to be y squared minus 2 times a, right? What's my a? It's the y, right? Times b, what's my b? 3 plus my negative 3 squared. I'm sorry, I didn't mean to write that. 3 squared, right? We do the math on this. What do we get? This is y squared minus 2, right? Let's just multiply this. 2 times 3 is what? 6, right? So this is just 6y. And then plus 3 squared is 9, right? So your choice of how you want to do this, right? But just know that this is very special, right? This is whenever you have the situation of something minus something squared. And so it's being multiplied by itself. It only works in that story, that scenario, right? But when I have two different parentheses being multiplied to one another, this doesn't work. The other two methods work. All right. So that's that. All right. Just for fun, let's throw out one of the test questions. Doo, doo, doo. Last test. Yeah. I mean, next test questions, y'all have them already. Mhm. Yeah. Yeah. Not Bryce's web work. Yeah. How I do this? I forgot. So this is asking me to solve. Let me rewrite this. N squared minus 6n plus 8 is equal to 0. All right? How do I solve this? I'm sorry? Factored? All right, let's factor it. So we know that this is a n squared, right? So that means I'm going to have two n's, right? I'm going to have one n here and another n here. Now, this is the hard part. I need two numbers that when I multiply them together will give me a positive 8, but when I add them together will give me a negative 6. What do you think they are? Negative 2, negative 4. Perfect, right? And you could check them, right? Negative 2 plus negative 4 is negative 6. Negative 2 times negative 4 is positive 8. Boom, right? Now here's a trick. Here's a trick. You got to set both of these individually equal to 0. So you're going to have n minus 2 is equal to 0, and you're going to have n minus 4 is equal to 0. Then you want to solve for n, right? So I'm going to add 2 over here. But you know what I do to one side of the equation, I have to do to the other side of the equation, right? So this is n is equal to 2, right? And let's call that n1. In the second one, I'm going to add 4 over here. And what I do to one side of the equation, I have to do to the other side of the equation, right? And why do I add 4? Because I'm trying to eliminate a negative 4, right? So this is going to be what? N2 is equal to positive 4. These are my answers, all right? If this was web work, you would do something like 2 comma 4 to enter your answer. You know, I don't know if you guys had any issues with web work or anything like that. All right. Any questions with this? Anybody? All right. Well, we are doing great. All right. I said we're gonna have a real simple day today. In reference to what I mentioned earlier about how some of you guys were trying this on the test, you were missing this lesson from today to get the full credit. All right. So let's talk about it. So this is solving radical equations. All right. So in this section, we will solve equations that have a variable in the radicand of a radical expression. An equation of this type is called a radical equation. So radical equation is an equation in which a variable is in the radicand of a radical expression, and it's called a radical equation. As usual, when solving these equations, what we do to one side of the equation, we must do to the other side as well. Once we isolate the radical, our strategy will be to raise both sides of the equation to the power of the index. Very important. Remember that. This will eliminate the radical. So solving radical equations containing an even index by raising both sides to the power of the index may introduce an algebraic solution that would not be a solution to the original radical equation. Again, we call this an extraneous solution, as we did when we solved rational equations. In the next example, we will see how to solve a radical equation. Our strategy is based on raising a radical with the index n to the nth power, and this will eliminate the radical. So for a greater than or equal to 0, right, the nth root of a, right, raised to the nth power is just a, right? So I don't know why I had that here. My mistake. This would be just a. That's so. All right. Right. So let me show y'all a quick example real quick. Is everybody done with the words, by the way? Can I? Okay. Okay. Appreciate y'all. So here's a real quick example, right? This is how to solve a radical equation. I'm gonna make that bigger so everybody can see. Don't judge me, I wear glasses. All right, so this is square root of 5n minus 4 minus 9 is equal to 0, right? So remember, anytime you don't see a little number on the root, you assume it's 2, right? So it's like this. It's like square root 5n minus 4 minus 9 is equal to 0, right? So what do we want to do here? We want to actually just solve for n. That's the goal, right? So the first thing you want to do is you want to isolate, right, your radical, right? Isolate your root. So what am I going to do? I'm going to add 9 over here, right, to get rid of that negative 9. Right? You owe $9, you paid the $9, now it disappears, right? But got to be fair. What you do on one side of the equation, you have to do the other side of the equation, right? So we're going to add 9 over here. So now what do I have? I still have that square root. This is square root 5n minus 4 is equal to positive 9, right? Now, to get rid of the square root, what do I want to do? I want to raise this entire term to the second power. Now, why did I do the second power? It's because the index is 2. So because that index is 2, I raise this to the second power. If the index was 3, I would raise it to the third power. If the index was 4, I raise it to the fourth power. Go ahead. I'm sorry? So if you don't see a number there, then just assume it's a 2. It's a square root. But if you do see a number there, like 3, 4, 5, 19, I'm just making it up, that's what you're going to raise it to the power, right? Now, again, what you do to one side of the equation, you have to do to the other side of the equation, right? So I have to raise this side to the second power as well, right? What you do to one side of the equation, you do the other side of the equation. Now, here's what's cool, right? The square root and the power up here are going to cancel out, right? So what's that's going to leave me with? Just whatever's in the radicand by itself. So this is 5n minus 4, just the radicand, equals, and then we have to do 9 squared. It's a little bit hard now. What's 9 squared? 81. Very good, right? And then that's it. So now I want to solve for n, right? So to solve for n, what do I have to do? Tell me. What? Good. Very good. Right, so I'm going to add 4 here to get rid of the negative 4. But what I do to one side of the equation, I do to the other side of the equation, right? So now I have 5n is equal to, what's that, 85? So what should I do after that now? What? Right. Right. And this is like 5 times n. So the opposite of multiplication is division. I'm going to divide by 5 here. What I do to one side, I have to do to the other. So now, right, little calculator, n is equal to what? 17. Appreciate that. I really had no idea. I was just asking. You know? And then that's it. N is equal to 17. Questions on this? Okay. Now, just to be thorough, right? Let me do it in purple. You know, we should always check our answers, right? Just to verify, does it work or not, right? So let me go back up to the original. Oh, here we are. So I have 5n minus 4 square root minus 9, right? And I don't know, allegedly that's equal to 0. Let's check it out and see. If I plug in the 17, this would be square root 5 times 17 minus 4 minus 9. Allegedly, that's equal to 0, but I don't know. What's 5 times 17? 85, right? So now we have square root 85 minus 4 minus 9. Allegedly, that's equal to 0, but I don't know. 85 minus 4, that's going to give me square root 81 minus 9, and allegedly that's equal to 0. Then we're going to have 9 minus 9, which I'm not sure, but allegedly that's equal to 0. And indeed, 0 is equal to 0, so that works. Right? Again, getting questions wrong in this class is optional, right? Y'all are all welcome to check your answers and get 100. I have no problem getting everybody 100, right? I like hundreds. You know, I even put a smiley face when there's 100, right? I don't know if y'all seen that, but yeah. All right, real quick. So how you guys feel about this? Would you guys like to try one, or do you feel like you got it and you want to move on? Try another one? You got it? Got you. Okay. Oh, you want to get the top? My fault, my fault. Hold on. My fault. So that's the original right there, the gray. And then this is the middle of it, or the whole thing. All right, it's a little bit harder because we got an M in it, but not too bad. So here you go. Try this out in case anybody's copying from the bottom. So this is square root 3m plus 2 minus 5 is equal to 0. So go ahead, try that out, and we'll see how this goes. Hmm. Drama, drama, drama. All right. Anyway, right? So I want to solve this equation. I have the square root of 3m plus 2 minus 5 is equal to 0, right? What should I do first? Tell me. Hmm? Right. Good, right? So I'm going to add 5 to this negative 5 to get rid of it, right? But what I do to one side of the equation, I have to do to the other side of the equation, right? So now I have square root 3m plus 2 is equal to 5. And what do I do next? What? Square. And how do I do that? Right. So I'm going to square this. But what I do to one side of the equation, I have to do to the other side of the equation, right? These will cancel. So now I have 3m plus 2 is equal to, what's 5 squared again? 25. Perfect, right? And what do I do after that? Subtract 2 from both sides. What I do to one side, do to the other. So now I have 3m is equal to 20, what, 3? And what do I do after that? By what? Right, I'm going to divide this by 3. What I do to one side, do to the other. So m is equal to whatever 23 over 3 is, right? And then yeah, something, you know? Appreciate you. But now, get it right by just yeah, yeah, that's all I'm looking for. Yeah. So then now we want to check our answer because we got to know, like, is this right or, you know, or is it not going to work, right? So we have square root 3m plus 2 minus 5 allegedly is equal to 0. I don't know. We're going to see. We're going to see, right? So this is going to be square root 3 times 23 over 3 plus 2 minus 5. And allegedly, that's equal to 0. Doing the math on this, the 3's will cancel. So I have square root 23 plus 2 minus 5. And allegedly, that's equal to 0. I don't know. This is going to become square root 25 minus 5. And I'm still not sure, but some people say that that's equal to 0, right? And then finally, we'll have 5 minus 5. And in some countries, they say that that is actually 0, right? And in fact, 0 is 0. So we know that works. All right. Questions on this? Anybody? All right, let's keep it moving. Let's keep it moving. All right. Before we go on to another question, though, just like humor me for a little bit, right? I want to give you guys instructions on how to do this, give you a little how to, and then we'll jump into our next question. All right. So these are just some notes for you guys. So this is how to solve a radical equation with one radical. All right. Step 1, isolate the radical on one side of the equation. Step 2, raise both sides of the equation to the power of the index. Right. Step 3, solve the new equation. Excuse me. And step 4, check the answer in the original equation. Okay. Any questions on this? Excuse me. You good? All right. So when we use a radical sign, it indicates the principal or positive root. If an equation has a radical with an even index equal to a negative number, that equation will have no solution. All right? This is going to save y'all like a good 30 minutes, maybe even an hour in your homework. That one sentence. All right? So check it out. Let's say I want to solve this. This is square root 9k minus 2 plus 1. I'm telling you that I could just look at this. Let me do it in black. I'm telling you that I could just look at this, right? And tell you that it has no solution. And how do I know that, right? You remember what step 1 is, right? You want to isolate your radical, right? So I'm going to subtract 1 from over here to get rid of that positive 1. But you know what I do to one side of the equation, I have to do the other side of the equation, right? Subtract 1. So this is going to become what? Square root 9k minus 2 is equal to -1. Now, we're going to finish this, but just logically speaking for a second, right? You know that there's nothing that I could put in that radicand to get a -1 out, right? There's literally nothing I could plug in there to get that -1 out. So this is an example of a question that has no solution, right? But let's finish it out so you can see. Let's finish it out, right? So same scenario, right? I want to get rid of the radical, so I'm going to square this. But as you know, what I do to one side of the equation, I do the other side of the equation, right? These two will cancel out. So this becomes what? 9k minus 2 is equal to +1. And then, just finish it how you would any question, right? We're going to add 2 over here to get rid of the -2 on the left-hand side. But what you do to one side of the equation, you have to do to the other side of the equation. I'm going to add 2. So now what do I have? I have 9k is equal to 3, right? 9k sounds like a really nice TV, right? So now we want to get k by itself, right? So I'm going to divide by 9, right? Because that's 9 times k, the opposite of multiplication is division. But what I do to one side of the equation, I have to do to the other side of the equation, right? So now I have what? K is equal to, let me see. 3 goes into 3 once, 3 goes into 9 3 times. So this is just 1/3. Boom. So that's my answer, right? Now this is looking a little complex because it's like, hold on, you just told me you have no solution, but you just came out with a whole answer. Let's plug it in and see what happens, right? So, what color? What color? What color? Let's do pink. Let's do pink. All right. So we're gonna check this, right? So allegedly, the square root of 9k minus 2 plus 1 is equal to 0. I don't know. And then if we have the square root of 9 times, I believe it's 1/3. Let me check because I forgot. 1/3, right? Minus 2 plus 1, allegedly, that's equal to 0. I'm not sure, right? When I do 9 times 1/3, this is going to be what? Square root 3 minus 2 plus 1. And in some places, they say that that's equal to 0, but I'm not sure. What's 3 minus 2 again? That's 1, right? So this is square root 1 plus 1. And I don't know, that could be 0. It might work. You don't know. Square root of 1 is just 1. So 1 plus 1, I don't know. That might be 0. Right? Let's add the ones together. What do we get? 2 does not equal 0. So therefore, this is not a solution. No solution. That should be in black. Hold on. No, that should be in black. No solution, right? And that's it. All right. So when you plug it in, if it doesn't work, you already know there's no solution. Or if you want to memorize the sentence up here, let me pull that to the side over here. Oh, I didn't mean to. I'll fix that in a second, right? When we use a radical sign, it indicates the principal or positive root. If the equation has a radical with an even index equal to a negative number, that equation will have no solution. You can memorize that, or you just go through the whole process. You plug in your answer and you verify that it works or doesn't work. That's it. Your choice.
Okay, so wait a minute, let's go back.
Yeah.
Up.
Up.
So let's see, illustrate.
Oh, you want this? You want the steps? Next door. This is a 23 class next door. Yeah.
So
Yeah.
for that equation.
Yeah. Yeah. Yeah.
For our class, the unknown. Moving the radical, that's no solution.
When it's equal to a negative
When
number.
it's equal to negative.
So like you see in this question, right? My first step was to subtract the 1 to get to isolate the radical, right? But you know that square root 9k minus 2 equals -1. There's nothing I can plug in there to get a -1 as an answer out. So just straight up, it has no solution. You know?
Because the slope is a minus.
Right. Because it equals a negative number.
Oh.
That's if you want to save time on the homework, but you can just go through it if you want. Go ahead.
In the test, you get it from, if you get the negative, you stop.
Yeah. Yeah. But if you're not sure, just go through the whole process. When you find an answer, plug in that answer and check it and verify that it doesn't work. You don't have to verify with so many steps, right? I like math, that's why I go step by step like that. But we all know that the square root of 3 minus 2 plus 1, that's gonna be 2, you know? But what?
This, semi.
Mhm. Go ahead.
But the big
Sorry about that. Mhm.
minus.
Right. That's why. That's what this sentence is saying here. So I know this equals 0, but as soon as you put that 1 over and you see it's negative, you know that there's nothing we could do, you know? Yeah. All right, so how do we feel? We good? Or y'all need to try another one, or y'all get the process? It's the same thing.
How about you, the next question with this, because I know what you got.
I got you. I got you. That's gonna be the next test. Yeah, yeah. All right. Oh yeah, yeah, yeah. I didn't take it out yet. That's my fault. Yeah. All right, this next part right here. This is not a mandate. This is a suggestion, right? You guys, I leave it up to you guys to do what you guys feel is best. So here it is. All right. All right. So let me just make it big enough. All right. If one side of an equation with the square root is a binomial, we use the product of binomial squares pattern when we square it. All right. So just let me do a little quick refresher and then we'll jump into the next example. So just to recap, when I say binomial square pattern, this is what I mean, right? When I say that a plus b squared is equal to a squared plus 2ab plus b squared, or a minus b squared is equal to a squared minus 2ab plus b squared, this is the binomial squares pattern, right? Go ahead.
But it's, of my cube,
Mhm.
but, I'm leaving from the sheet.
Yeah.
It's X, I was. Oh,
Yeah,
that's it.
it was there. Yeah, yeah. Yeah, the answers to all the questions was on the formula sheet, to tell you the truth. That's why I'm saying, like, when you guys do your homework, like, look at the formula sheet, use the formula sheet to help you with the answer, you know? And the calculator, of course, but mainly the formula sheet, you know, it's there to help. All right, let's take a look at an example, next example, right? So just walk me through this because I feel like you guys know enough information now. Tell me what to do. Go ahead.
So, you know, sorry. But I, for each other side, pay the other. Zero. Your, that's a positive thing.
Hmm. Okay, okay. Almost there. I want to isolate the radical. That's the goal because that radical is a pain. So what should I do first? Subtract the one, right? Hold on. Hold on 1 second. All right, bear with me 1 second. But yes, subtract one is the first step. Just bear with me 1 second. We are loading. We are loading. Okay, yes. Subtract one. And what you do to one side, you do to the other. Sorry about that delay. So we have the square root of p minus 1 is equal to p minus 1. I want to get rid of the square root that's bothering me. How do I get rid of it? Right. I'm going to square this to get rid of the square root. But you know what I do to one side of the equation, I have to do to the other side of the equation. So now you can do one of two things. You can use your pattern, your binomial square pattern here if you want, or you just do it out the way you normally know how to do it. Your choice, right? So these will cancel out. So this is just p minus 1, right? Is equal to, I'm going to use a square pattern, right? So this is going to be what? P squared minus 2 times a, which is p, times b, which is 1, right? Plus the b squared. A little bit of math. This becomes what? P minus 1 is equal to p squared minus 2p plus 1, right? And then now you can just put everything on one side. I'm going to add 1 over here. What do I do to one side? I got to do to the other. I'm going to subtract p from over here. What I do to one side, I got to do to the other. So now I have 0 is equal to p squared minus 3p plus 2, right? And you already know what we're going to do next. We're going to factor this, solve it for 0, all that good stuff. So this will be 0 is equal to, what's this? P minus 2, P minus 1. You guys can factor however you guys want, all right? Then we want to set these both equal to 0. So you have P minus 2 is equal to 0 and P minus 1 is equal to 0. I'm going to add 2 over here where I do to one side, do to the other. So I have P1 is equal to 2. I'm going to add 1 over here where I do to one side, do to the other. This is going to be P2 is equal to 1. And that's it. Now, of course, I'm still going to have to check the answers, right? But this is the whole process right here. Questions on this so far? Remember, step one, you want to isolate the radical, right? You want the radical on one side, you want everything else on the other side. Then you're going to square both sides to get rid of that radical, right? Because the radical is a problem with us solving this. Go ahead. Which P represents the one, which one represents the two. Like you're asking, where did the two come from? Got you. Yeah. Oh, back into the original question. Yeah, 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 yeah. So this is how I'm gonna check it, right? So the original question was square root p minus 1 plus 1 is equal to whatever p is, right? So I'm gonna take 1 second. I'm gonna take one of these answers. So I have 2 and 1, right? Let's say 2, for example. I'm gonna plug that in, right? So I want to know if square root 2 minus 1 plus 1, allegedly, that's equal to 2. I don't know, right? So let's see. 2 minus 1, this is square root 1 plus 1, allegedly. That's equal to 2. I don't know. 1 plus 1, in some countries, they say that that's 2. But over here, we know that 2 is equal to 2, so we're good to go. It works, right? And then now we want to do that again with the other number, right? I'm just going to change the color just for dramatic effect, but you get the idea, right? So this is going to be p minus 1. Hold on, let me try that again. P minus 1 plus 1 is equal to p, right? So now I'm going to plug in 1 and see if that works, right? So this is going to be 1 minus 1 plus 1. Allegedly, that's equal to 1. I don't know, right? 1 minus 1, that's like 0, square root of 0 plus 1. Some people say that that's 1, but I'm not sure, right? Square root of 0 is just that, so 1 is equal to 1, and we good to go. Both of these are answers, right? Sure, sure. So just to clarify, we good over here, right? Hmm. Questions on this? Anybody? Homework for this has already been posted, right? Y'all can knock that out like in the meantime. I do have more examples, but to be honest with you, they're all the same stuff like this. Mhm. On web work, yeah, yeah. Mm-hmm. But it wasn't one that was open yesterday. That's the one I'm talking about. Yeah, that's this. Yeah. Mhm. So here's another little hint. So sometimes the solution of a radical equation results in two algebraic solutions, but one of them may be an extraneous solution. Blah, blah, blah. When you answer these questions, right? Check your answers, plug it in, verify that both answers work. And that's it. All right, go ahead. Yeah. Like I won't be there, but they'll be there. It's gonna be open. I'm there today and Wednesday. Yeah, yeah, yeah. Yeah. But- yeah, yeah, go ahead, go ahead. Yeah, there's good people there. Yeah. I got you. All right, works. That works. All right, how do I do this? A little complicated, this question. What do I want to isolate first? Okay, you can control this too. All right, so how do I get rid of the plus two? Right, very good. And what else? So we have square root, almost. We have square root r plus 4, right? Minus r is equal to negative 2. What should I do after that? Almost. So remember, I want to isolate the radical, right? So what else I can add r, right? To both sides. Very good. So now what do I have? I have square root r plus 4, is equal to r minus 2. Now, how do I get rid of this radical? Exactly, right? I don't want to square both sides here. What I do to one side, I gotta do to the other. So now I just have very simply the radicand, which is r plus 4, is equal to, now I'm going to use the binomial square pattern, but you guys can FOIL it or distribute it however you want to do it, right? So this is going to be, let me see, r squared minus 2 times a, which is r, times b, which is 2, right? Plus the 2 squared. Yeah. I'm using the pattern right here, right? But if you don't want to use the pattern, right, you want to FOIL it, go ahead, you'll get the same answer. Better safe than sorry. I'm just feeling comfortable using this, all right? So this is r squared minus 4r plus 4. Excuse me. After that, I want to get everything on the same side. So I'm going to subtract 4 from here. But you know what I do to one side of the equation, I have to do to the other side of the equation, right? And then I want to subtract r from here to get everything on the same side. But what I do to one side of the equation, I do to the other side of the equation. So now what do I have? I have 0 is equal to r squared minus 5r. Greatest common factor between these two terms is r. Factor that out, so this becomes 0 is equal to r times r minus 5. After that, very simply, just set both of them equal to 0. All right. So this is just r equals 0, r1. That's one answer. And the other one is going to be r minus 5 equals 0. I'm going to add 5. So r2 will equal to 5. But now I got to check, does these answers work, right? Because I'm not sure. I can't tell by looking. I can't tell as I was doing the question. This was hard. Let's be honest. This was hard, right? Oops. So now I want to check this, right? So square root r plus 4 minus r plus 2, allegedly that's equal to 0. Let's see. So I have one answer of 0. Let's try the 0 answer. So this would be square root 0 plus 4 minus 0 plus 2, and allegedly that's equal to 0. This is going to be square root 4, right? Minus 0, you know, is nothing, plus 2. Allegedly, that's equal to 0. This is going to become 2 plus 2. And in some places, that might be 0, but in this place, 4 does not equal 0, right? So I know that 0 is not an answer. Let me try out 5 because I'm not sure, right? So this is what? Square root r plus 4 minus r plus 2 equals 0, allegedly, right? This is going to become square root 5 plus 4 minus 5 plus 2. Some people say that that's equal to 0, but I'm not sure. 5 plus 4, this is going to be square root 9 minus 5 plus 2. And in some places, that could be 0. This will become 3 minus 5 plus 2. Still not sure, but that might be 0. 3 minus 5, this is going to give me what? Negative 2 plus 2. Some places that's 0. And in this case, 0 is equal to 0. So we're good to go. So 5, that's a solution. Hold on. 5 is a solution. And that's it. Questions on this, anybody? Long, yeah, sure. So long story short, when you're doing the questions, do them and then just check your answers no matter what. And you'll always be good. Sure. You're welcome. All right. We feel good? No questions? All right. Couple more examples. Nothing crazy though. The same thing that we've been doing. All right. Sorry about that. When there is a coefficient in front of the radical, we must raise it to the power of the index 2. Okay? So I'm gonna do this question, which is 3 times square root 3x minus 5 minus 8 equals 4. I'm gonna do this question in the way that they intended us to do it, but you do have another option. Watch this. So again, I want to solve for x here, right? So I'm going to add 8 over here. Everybody agrees that's the first step, right? What you do to one side of the equation, you do to the other. Right? So now I have 3 square. Got to make it look bigger, right? Square root 3x minus 5 is equal to, what's that? 10, 12, right? Technically speaking, I could just divide that 3 on both sides and I'm back to the square one, right? But according to the hint that they're giving to us, right, you could raise this to the second power to get rid of the root. This is another way you could do it, right? Me personally, I would have divided by 3 on both sides and kept going, but to each his own, right? Let's just see what happens when you do it this way. So this is going to become what? 9, right? Because 3 squared is 9. 9 times the radicand, which is 3x minus 5, is equal to 12 squared, which is 144. Again, I want to solve for x, right? So what should I do next? Not distribute, not FOIL. Starts with a D. Divide, right? Because this is 9 times this. I want to get rid of the 9 on this side. But what I do to one side of the equation, I do to the other side of the equation, right? So now what do I have? What is 144 divided by 9? Say it again? 17, okay. And then just finish solving for x, right? You're going to add 5 over here. What you do to one side, you do to the other. 3x equals 22. Is that 22? Am I right about that? Okay, and then just divide by 3. It's 16. Okay, no problem. All right, so that's 21. So x is equal to 7. That's it. Questions on this? Anybody? So that's just the idea, you know. As usual, you should check it. All right. Let's just do a really quick check just to save time. So I have 3 times square root 3 x minus 5 minus 8. Allegedly, that's equal to 4. 3 times square root 3 times 7 minus 5 minus 8. Allegedly, that's equal to 4. 3 times 21 minus 5 minus 8. Allegedly, that's 4. 21 minus 5, what's that? 16. So 3 times square root of 16 minus 8. Allegedly, that's 4. Square root of 16 is 4. So this is 3 times 4 minus 8. Not sure, but they say that that's 4. 12 minus 8. Not sure. And then 12 minus 8, what's that? Say it again. 4. And 4 equals 4. That's it. All right. Questions on this? Anybody? Like I said, for me, I'm not really a fan of this method. So take this as a hint, but I'm not forcing y'all to do it. If it was me, I would have divided by 3 and then just finished this all out. But that's just my preference. I want to give you guys options. All right. I'm sorry?
The check.
The check. Gotcha. You're welcome. No problem. No problem. You want to see the original?
Yeah.
This is the bottom here. Oh, no, final answer 7. All right. So let's kind of sort of change gears a little bit. A little bit, a smidget, not that much. We're still in the same lane, but we allowing one car to pass us because they're not driving right. Right. So we want to solve radical equations with 2 radicals now, right? So if the radical equation has 2 radicals, we start out by isolating one of them. It often works out easiest to isolate the more complicated radical first, right? In the next example, when one radical is isolated, the second should also be isolated. Sometimes after raising both sides to an equation to a power, we will still have a variable inside a radical. When that happens, we repeat steps 1 and 2 of our procedure. So we isolate the radical and raise both sides of the equation to the power of the index again. And then we get our final answer. Let's take a look. Let's take a look. So now in this scenario, right, I have the square root of m plus 1 is equal to the square root of m plus 9, right? So you see this square root of m plus 9? In my opinion, this is more complicated, right? Because it's together like that. So that's what I want to isolate. And to get rid of that square root, I'm going to square it. But I got to be fair. When I do the one side of the equation, I have to do it to the other side of the equation, right? So you already know on the right-hand side, this is just what? M plus 9. But on the left-hand side, right, let's use that binomial squares pattern. This is going to be square root of m squared plus 2 times a, which is square root of m, times b, which is 1, plus b squared. right? Wait, why did I say b? I'm sorry, 1 squared. Sorry about that. Let's do a little math on this. These will cancel. So I have m plus 2 square root m plus 1 is equal to m plus 9. Now in this new equation I have on the bottom, I want to isolate that one radical by itself because the radical is a problem, right? So how am I going to do that? I'm going to move everything to the other side. I'm going to subtract m from over here. But what I do to one side of the equation, I have to do to the other side of the equation, right? I'm going to subtract 1 from over here. But what I do to one side of the equation, I do the other side of the equation. Now I have 2 square root m is equal to 8. For me, I want to divide by 2 just to get rid of it. But what I do to one side, I do to the other. So I have square root m is equal to 4. So now I want to square it to get m by itself, right? I'm going to square this. What I do to one side, I got to do to the other. So now I have m is equal to 16. And that's it. Questions on this? So I had to do a double isolation. All right. So just I had to do a double isolation here, right? I had a radical on the left and a radical on the right. I isolated the more complicated radical first, then I squared both the sides to get rid of it. But after doing that, I had an answer that still had another radical in it. So I had to square it again just to get it down to the final answer. All right. Questions on it? So now, I got to check the answer, right? Can't just do it and be good, right? Because some of these answers is coming out and it might not even be right, you know? So we got to check and verify. Wait, what was the answer that I came out with? 16? All right. So let's check this out. This is a check. So allegedly, square root m plus 1 is equal to the square root of m plus 9. I don't know if it's true, but let's see. So square root of 16 plus 1 allegedly is equal to square root of 16 plus 9. Let's check it out. Square root of 16 we know is just 4 plus 1. Allegedly, that's equal to square root of, what's that, 25, right? And in some places, 5 does equal 5, so we're good to go. All right? Once you have the left side equal to right side, you're good to go with your check. Okay. Questions on this, anybody? You feel like we got it? We can move on, or y'all need to see another one? Oh, the bottom. I got you. No problem. There you go. Yeah. Oh, the top? Oh, you want to say like the original question? Yes. Yeah, like this? You're welcome. All right, just humor me for a second, y'all. I just want to give y'all some notes before we jump into the next example. Next example is the same thing like this. So here you go. This is a little procedure. So this is how to solve a radical equation. Step 1, right? Isolate one of the radical terms on one side of the equation. Step 2, raise both sides of the equation to the power of the index. And step 3, are there any more radicals? If yes, you got to repeat step 1 and 2. If no, then you just solve the new equation. Step 4, check the answer in the original equation. All right. Questions on this? Anybody? All right. Let's look at another example. Same thing as what we just did. You know? So I have square root q minus 2 plus 3 is equal to square root of 4q plus 1. Which is the more complicated radical here? 4q plus 1, right? So how do I get rid? I'm just in black. How do I get rid of the radical? How do I get rid of this radical? You square it, right? So I'm gonna do this and square it. But as you know, I do the one side of the equation, I have to do to the other side, right? Excuse me. So on the right hand side, you know we have 4q plus 1, right? On the left hand side, now I'm going to use that square pattern. Again, up to you. You guys can distribute it, no problem, right? So for the square pattern, I have what? Square root q minus 2 squared, right? Um, plus 2 times my a, which is square root q minus 2 times my b, which is 3, right? Equals that. So this is going to be what? Q minus 2 plus 2 q minus 2 plus 9 is equal to 4q plus 1. The issue here is I still have a radical, right? So let's move everything to one side, right? So I'm going to subtract q from over here. What do the one side do to the other? So now I have negative 2 plus 2 square root q minus 2 plus 9 is equal to, what's this? 3q plus 1. All right. Let's combine like terms. Negative 2 and 9 is 7. So this is 2 square root q minus 2 plus 7 is equal to 3q plus 1. I'm going to subtract 7. So now we have what? 2 square root q minus 2 is equal to 3q minus 6. Go ahead. Oh, yeah, 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 yeah. There you go. That's the original. What?
Um, Q minus two and
Because in this case, A is the square root of q minus 2, and B is just a 3. Oh, it is. Oh, yeah, you're right. It is that. I missed the 3 right here. So this should be 6. Good catch. There we go. So now you can either square both sides or you could divide by 6 on both sides. I'm going to square both sides just because that's what they want us to do. Excuse me. So I'm going to square here to get rid of the radical. So now what do I have? I have 36 times the q minus 2 is equal to, oh boy, what's this? 3q squared minus 2 times 3q times 6 minus 6 squared. A little bit of math, right? Now what am I gonna have? I'm gonna have let's say 36q. I'm just distributing 36q minus 72 is equal to 9q squared minus Appreciate that. Minus 36. I'm going to subtract 36q from here. I'm going to add 72 over here. So I have 0 is equal to 9q squared minus 72q plus 36. And we want to set both of these equal to 0. You got what? Yeah, you could do it like this. 3q squared is 2 times 3q plus 6 squared. This would be 3q. This is minus 6 squared. Yeah, that's right. So this is what? 3q minus 6 and I'm sorry, equals 0. And 3q minus 6 equals, yeah, yeah. So what this is like this. It's 3q minus 6 times 3q minus 6. That's why I'm doing it like that, right? Of course, equals 0. So set both of them equal to, solve for q in both. Same thing, add 6, add 6. 3q is equal to 6, divide by 3, divide by 3. q1 equals 2, add 6, add 6. 3q is equal to 6, divide by 3, divide by 3. Q is equal to 2. So, not quite part of this class, but what you would say about this question, right? You get the same answer out twice. So, this answer has a 2 with what's called a multiplicity of 2, right? That's how many times the number repeated itself. You'll see that in Math 30, right? But that's what happens when you have a repeated answer like such, right? Same thing, you want to plug it in to check it. Give me 1 second. Do I have time? Yeah, I'm good. I am good. Let's check this out. So I forgot what answer I got. 2, right? So let's verify this. So allegedly, square root q minus 2 plus 3 is equal to square root 4q plus 1. This is a check, by the way. So I'm saying if I plugged in 2 minus 2 plus 3, that should equal the square root of 4 times the 2 plus 1. Right? Let's do the math on this. 2 minus 2, this is just square root 0 plus 3. And allegedly, that's the same thing as 8 plus 1, square root of 8 plus 1. So apparently 3 allegedly is equal to the square root of 9. I don't know, but 3 is equal to 3, so we're good to go. So yes, this 2 that we found down here is an answer. Questions on this, anybody? What? So when I was doing this question, just to clarify, this is my A, this part right here. And then this is my B, right? So that's how that went about. If you're unsure, just multiply them together, FOIL it, distribute it, whatever, and then get out the same answer. Right? I was using a shortcut. You do not have to use that. Go ahead.
Again,
Hmm?
just asking.
Yeah.
Is.
Yeah.
See where, when we get an absolutely wrong answer, if we took the Q squared, right?
Q squared.
And be like. Now, again, this square, Q squared minus Q plus minus Q plus 4. That screw that whole thing up. So you have to do it the way that, I'm just asking.
Yeah, I'm trying to figure out where you are. You're at the Q minus 2, right? You saying if I square that?
Like sparing any, like, I'm doing any other thing, doing what I just said. That was
Like without distributing it and stuff like
Yeah.
that. Got you. We still would need to. You had two options here. We could do the Q minus 2 plus 3, square that, or you could have subtracted the 3 to the other side and done the square root of 4Q plus 1 minus 3 squared. You would have came out with the same answer, you know? But we still needed to do that distributing and all of that to get this final answer here.
Yeah.
But this is the sauce right here. This is it.
It's a part of the answer, is the test.
You should do it, yeah, because you don't know if the answer will work or not. You know? Yeah. But I mean, if you don't do it, I won't take points off if the answer is correct. But if the answer is no solution and you give me like your x is equal to 5, I'm like, damn, you know? Got you. There you go. Okay. So any questions on this? Anybody? Good. All right, that's all I have for today. You know what? I forgot to put out the attendance. Let me do that real quick. Yeah, just bear with me 1 second. Just let me know when I could take this down. Appreciate y'all. And get to, I can do it on loose leaf today. All right, when you guys get a chance, come up and sign. May I take this down?
Yes.
Anybody? Can take this down? Appreciate y'all. Thank you so much.
Okay.
Thanks.